Afternoon, and thank you all for hanging out. I know it's been a long day, and many of you are probably suffering from pitch fatigue. So I'll do my best to keep things light, entertaining, or informative, and maybe even entertaining. So I also want to thank the folks at JLABS for making this great facility available to us. And I want to remind everybody that this entire room, everything that we're experiencing in this room, is made possible because of an access to electricity. In fact, everything in the modern world that we experience is made possible by electricity. But the reality is that there's 40% of the world's population, roughly 3 billion people, that suffer without access to reliable power. I mean, it's hard to believe. Here we are, it's 2019. It's the world's at our fingertips, but nearly half of the population doesn't have access to this fundamental resource. Why? Well, the problem is the power grid, the grid that electrifies this building and the homes that we all live in, it just doesn't extend all around the world. And it never will, because grids are just really expensive to install. And so our team has a background in building energy efficient products, like the very best performing wind turbine blade ever built. So we had an idea that there had to be a better solution, and the answer is going to be to make the power where the people are, provide the power direct to them, eliminating the need for the transmission system, and generate that electricity from a renewable source. So for those that are living and working at the grid's edge and beyond, well, the vast majority of them that have power, they get them from diesel generators, which we all know pollute, but beyond the environmental consequence of running a diesel generator, they're really expensive to operate. So we set out to develop the world's first commercially sized mobile wind turbine. The entire system fits in a single 20-foot shipping container. And when it arrives on site, the entire wind turbine can be set up by one person in just 1 hour's time. No site improvements, no heavy equipment, no specialty training for that matter. And a couple other benefits of the portability, namely the fact that our mast lays down, is one, any service work is done right here at ground level. Nobody ever has to climb way up there to work on the turbine. And two, and this is a big one right here, is traditional wind turbines, they're all designed to withstand that 100-year storm that seems to be happening every couple of years these days. And where our machine, on the other hand, we were able to go after the maximum performance possible in every aspect with the confidence of knowing, should that storm present itself, the machine will autonomously lay down, and that's how it protects the system. So here's what the machine looks like in an actual application. And while the portability of the system is novel, it's the performance where we've done the most important innovation. And to that end, we have a turbine blade that is over twice as efficient as the incumbent technology. And we achieved this high efficiency. We modeled over 2 million unique blade shapes before we found the one that best fit what we were looking to accomplish. And this high efficiency, it is complemented with a feature that it is the most important development of this whole project. And it's something that we call dancing with the wind. And what that refers to is our wind turbine's unique ability for the rotor RPM to speed up and slow down, precisely matching the changes in wind speed, maintaining an optimized tip speed ratio throughout those changes so it can maintain that high efficiency and effectively capture the exponential power that is available in wind gusts. And so I've got a couple of graphs on this slide here. This is just our power curve. This says we're really efficient and we make good power in low wind speeds. But down here, these are two sine waves of the same wind condition. This is wind speed, and this is the kinetic energy in that same in that same curve. And what we do is we follow that kinetic energy curve and we take advantage of this exponential power. So what this results in, blade that's twice as efficient, and when you add the benefits of dancing with the wind, that's roughly another doubling of performance. So 2 + 2 = 4x better than the incumbent technology.
What's the ideal wind speed for your machine?
We targeted a 10-mile-an-hour wind speed as the point where we wanted to start making good, reliable power. So that is what I would consider a minimum viable wind speed. As the wind speed increases, we do better and quite quickly. Now, any time that you generate power from a renewable source, you need to have an energy storage component in the mix to buffer that power. And to that end, we're able to put a very significant amount of energy storage right in the belly of our trailer, up to 400 kilowatt hours. And to put that into perspective, that is the average US home running at full tilt for 16 plus days. So what this all results in is a wind turbine that can provide enough power for up to 20 US homes, a remote village of 150 or so people, or a good-sized job site. But that's not it. This is a fully connected IoT device, providing full communications both to and from the machine, wherever it may be. Wi-Fi, cellular, satellite, providing real-time data analytics, telemetry, remote control, operation. I mean, just think about it. Here, we live in a data-driven society. Everything is about data. But yet, big parts of the world are being ignored because they're not connected. And this is our wind turbine is a tool that has the promise to connect many of these markets. Now, it would be common to assume that, hey, wow, this portable wind turbine with all its neat features, it's got to be really expensive. But it's not. We sell our wind turbine for the same price as the incumbent technology. But with our superior performance, the cost of generated electricity is going to be a fraction of theirs. And I'll also remind you that those guys, they take over 2 years to set up. And we set up in just 1 hour's time. Now this attractive cost per kilowatt hour creates many opportunities and makes us the preferred generator in both standalone and hybrid configurations. But, you know, if I spend a second to talk about the competitive landscape, well, we produce power in that 10 to 30 cent per kilowatt hour range, depending on wind speed. The diesel generator, if you're buying your fuel at $4 a gallon, it's going to produce power at $1 a kilowatt at best. It's probably more than that. Solar is wonderful. I love solar. But the sun is only out a few hours out of the day. So if you want to provide around-the-clock power, well, one, you need a massively oversized system. And two, a bigger consequence is the storage component to get you through those 18 or so dark hours at night to get you through the night. Now, and then to put this in perspective, this right here is probably 35 to 40 cents per kilowatt hour, and it's going like this. So this right here, this might just be the most important slide of them all, though. Not only, when you use a Uprise Energy mobile power station instead of a diesel generator, not only will you save $1 million in fuel costs over the life of the machine, you're also going to eliminate roughly 1 million pounds of CO2 emissions. Big deal. Now, in the energy world, there is no silver bullet that answers all energy needs. It's really a matter of selecting the correct technology for the application. And for many applications, our system represents a strong competitive advantage for areas like temporary power, islands, electric vehicle charging stations, commercial, construction, agriculture, disaster relief, military applications, and then the biggest of them all is the humanitarian. So in our development cycle, we built an alpha prototype, we built a beta prototype, and we built a Charlie. And the Charlie is what we're commercializing right now. We're building our first production run at our Kearney Mesa facility as we speak. And we're pretty excited. And on this level of development, it's allowed us to gain traction, very significant traction around the world. Turns out, when you develop a system that is life-saving and it really responds to some significant pain points in a unique and preferred manner, selling these units is not difficult. So now, but on top of selling the equipment as an OEM, well, we're also going to license our IP to other OEMs. We're going to generate recurring revenue through subscription packages on our data layer. And then once the 10 kilowatt system that I've been talking about is fully commercialized, we have concepts around a 50 and 100 kilowatt unit that both fit in 40-foot containers that we will be bringing to market in due time. Now, as I alluded to earlier, this is not our first rodeo in wind energy. We ran quite a significant business that was in the blade repair, manufacturing, and field services business with a few hundred employees. And probably that crowning achievement was when we developed this blade here, which was the Star Blade, in collaboration with the US Department of Energy, that is to this day the very best performing blade ever built. And so from our long history of building custom yachts and working in the wind business over 40 years here in San Diego, we've been able to cherry pick an all-star team to come together and develop this innovative product that just leaves really no doubt that the Uprise Energy mobile power station is the right product at the right time for the grid's edge and beyond. Thank you.